Good morning, sir.
Very good.
Good
Good
morning,
morning.
sir.
Very good. Good. Good.
Good morning.
So started joining one by one. Good.
Sir, I have one question.
Yes, ask.
So, what we have to write in physics notebook?
In physics notebook, you have to write the notes that will be provided when the school commences. Otherwise, the same PPT I will be sending on your personal, you can say, WhatsApp. Because at this moment, I don't know whether these numbers are continuing or not.
Okay, sir.
So,
So till now, nothing should be written in physics notebook.
yeah, but if you want to write, if you can make the notes yourself, it's better. Otherwise, I'll be sending it.
Okay, sir.
Okay. So by the time the students come, let us start. And what we have done so far was about Gauss theorem. This is what we have to start. Okay, before we come to the Gauss theorem statement, the first thing that we have studied was regarding electric flux, the product of electric field intensity and the area and the area. And the electric field we were talking, it will be always passing perpendicular to the surface and pointing outward. Perpendicular to the surface and pointing outward. So this will be the range of the field, and on that field the electric flux which will be calculated will be based on these number of lines which will be passing through the surface, perpendicular to the surface and outward. Because orientation makes a difference. Orientation is definitely making a difference in that case. Now, suppose you are having a point charge. Now, this point charge obviously will develop an electric field which will be moving in all the direction, and consequently we will be getting the formation of a spherical electric field around the point charge. Is it clear? If we take a point charge, this point charge will be releasing the electric field in all the direction. And when we join all these points, what we will be getting? We will be getting a sphere. So that means for a point charge, the spherical case will be there. The surface will be considered as a sphere. Now, if suppose instead of point charge, we take a linear charge. Suppose this is the charge. This is the entire body which is charged. Now again, the electric field will be pointing outward and perpendicular to it in all the direction. That means in this case, what will be the electric field surface? It will be a cylinder. It will be a cylinder. That means for a linear charge body, if the body is having a linear charge in the form of a line, the surface will be resulting in the formation of a cylinder. But if it is a point charge, the surface will be considered as a sphere. So these 2 points you have to remember. So let us start now with the actual statement and concept of Gauss theorem. It was given by a German scientist, Gauss. And what he said, he gave a relation to us between electric flux and the area concept. Electric flux and the area concept. So I'll just share the slide in between. I'll come back to you. So let us start our today's topic, and it is Gauss theorem. Yes. So Gauss theorem was given by, as I told you, a German scientist, Carl Gauss, who gave the relationship between electric flux through a closed surface. Through a closed surface. That means we have to consider the surface as a closed one. That is what I was telling you. If you take a point, it will be making sphere. If you take a linear, it will be making a cylinder. So he gave the relation between electric flux through a closed surface and the charge enclosed by the closed surface. One of the very important line. Charge enclosed by the surface. Whatever surface we are considering, how much charge is inside it and closed by it. That will be the charge to be considered, not outside. Whatever charge is inside that surface, that we have to consider. So according to Gauss theorem, the total electric flux through any closed surface in free space is equal to 1 over epsilon naught times the total charge enclosed by the surface. Suppose a surface is having a point charge Q. Suppose a surface is there in the form of a point. It is having point charge Q. Surface formed will be sphere. This is clear. It means that sphere is enclosing point Q as the charge. And total electric flux due to this charge will be 1 over epsilon naught times that charge. That means Q. So phi will be equal to Q by epsilon naught. Now similarly, if suppose you are having a linear charge, suppose you are having a line charge, then also what will be the charge on the line? Q. And the surface formed will be a cylinder. And whatever charge is enclosed in that cylinder, that will be also Q. So again, according to Gauss theorem, total electric flux will be again 1 over epsilon naught times into Q. So whatever is the shape of the surface, according to Gauss theorem, electric flux will be equal to 1 by epsilon naught times the charge which is enclosed by the surface. Now, what is a Gaussian surface? देखिए, क्या होता है कि when you talk about a sphere or when you talk about a cylinder as a surface, actual thing is it is a very large surface. So what we do, we consider a very small section of that surface. We consider that very small section of that surface, which is called Gaussian surface. And we will try to find the electric flux on that Gaussian surface, or to find it for entire surface, what we will do? Integrate. Are you getting my point? When you take, suppose the surface as a sphere, it will be having a large area. So in order to find the electric flux, we will do what? We will consider a Gaussian surface. Gaussian surface means a very small surface of that given surface, such that the intensity of electric field at all the point is same. So that is called a Gaussian surface. So that entire surface, sphere is a Gaussian surface. Cylinder is a Gaussian surface. So as I had told you earlier also, same thing is written here. If for a point charge, the Gaussian surface will be a sphere. And for a linear charge, the Gaussian surface will be a cylinder. The Gaussian surface will be a cylinder. Now, Gauss theorem was a phi is equal to what? 1 over epsilon naught times into q. This is what we have to prove also. The proof of Gauss theorem. We will prove that the phi, which is the electric flux, is equal to q by epsilon naught or 1 by epsilon naught times the q. Now see, we have considered a point charge q. You can see in the diagram. We have considered a point charge q, which is obviously making a Gaussian surface obviously as a sphere. It is making a Gaussian surface as a sphere. And that sphere will be, suppose we want to find out the electric flux at a point on this sphere which is lying at a distance of r. What is the radius of the sphere? That will be r. What we have considered? We have considered a point charge. Due to this point charge, a Gaussian surface is being connected. It is being produced, which is in the form of a sphere. If you want to find out how much electric flux is there at that point P, which is at a distance of r from the charge Q, what we will be doing? We will be doing that we have to consider a small Gaussian surface of area element which will be ds. Now clearly electric field will be perpendicular to the surface and moving radially outward. Electric field will be moving radially outward and area vector is also moving outward. That means both of them are parallel to each other. What is the direction of E and ds? The direction of E and ds is same. E and ds is same. So according to the formula, or you can say according to the concept of Coulomb's law, there is a charge Q at the center. Let us say there is a unit charge at P also. So electric field intensity, that is capital E, is equal to 1 over 4 pi epsilon naught Q by R square into unit vector R. Just a second. So, what is the electric field intensity due to this plus Q charge on every point on the spherical body will be 1 over 4 pi epsilon naught. Hello. Q by R square into unit vector R. Now, as I have told you, in order to find the electric flux for the entire surface, first of all, we will try to find the electric flux at a very small area element that will be considered on the Gaussian surface having a vector ds perpendicular to the surface of the element. Now electric flux, everybody knows it is equal to phi, which is equal to E dot ds. E dot ds. Now E, everybody has calculated just now. What is the electric field intensity? That is 1 by 4 pi epsilon naught q by r square into unit vector r dot ds. Dot ds. So d phi will be equal to 1 over 4 pi epsilon naught q by r square into unit vector r dot ds into unit vector n. This is the unit vector perpendicular to the surface, and clearly because this vector n and r, they are in the same direction, they are parallel to each other, so the angle will be 0 degree and cos 0 is 1. So d phi will be equal to E ds. E की value put करके you can go for ds. And this is phi. Find total electric flux. इसको हमने integrate कर दिया surface integral निकाल करके. Now everybody knows that 1 over 4 pi epsilon naught q by r square is a constant term. So it will come out of the integration. And what is left? Surface integral of ds. Surface integral of ds. ds means the Gaussian surface. Uska surface integral means its area. Now, what is the area of the Gaussian surface? Obviously, Gaussian surface is a sphere. So the area of the sphere is 4 pi r square. Area of the sphere is 4 pi r square. That means surface integral of ds will be equal to 4 pi r square. So when you substitute this value in the above equation, what we will get? We will get phi is equal to this. Now 4 pi cancels with 4 pi and r square cancels with r square. What is left? 1 over epsilon naught into q. And this is what is called electric flux. 1 by epsilon naught times the total charge enclosed, that means q. So this proves Gauss theorem. Once again, I'll just revise what we have done. Gauss theorem says the total charge enclosed by a surface, if it is q, the total electric flux will be equal to 1 over epsilon naught times that charge. In order to prove that, हमने क्या किया? We have considered a small charge q at a point O. To find the electric flux at a distance of r, हमने एक Gaussian surface को consider किया. And as I have told you, कि point charge के लिए Gaussian surface will be a sphere. It is a sphere of obviously radius r. Now at any point on this Gaussian surface, what will be the electric field intensity? Coulomb's law, 1 over 4 pi epsilon naught into q by r square into unit vector r. This is E. And what is electric flux? Phi. That is equal to E dot ds. So in order to find the surface integral of the sphere, what we do? We consider a small area element on the sphere where we find the electric flux first. So d phi will be equal to E dot ds. where ds is the small area of sphere. Where ds is a small area of ds. Value of surface integral, that will be the area of sphere 4 pi r square. Substitute that value and get the equation phi is equal to 1 over epsilon naught into q. So next is one of the very important article which we are going to discuss and use again and again. That is to prove the Coulomb's law using Gauss theorem. Everybody is clear with the concept of Coulomb's law. It talks about the force of attraction or repulsion between the two charges which are placed at a distance r apart. That was 1 over 4 pi epsilon naught q1 q2 by r square. This was Coulomb's law. Now this Coulomb's law we have to prove using Gauss theorem. So we will be using Gauss theorem and we will reach to the concept of Coulomb's law. तो उसके लिए हमने सबसे पहले क्या किया? We have considered 2 points A and B where we are placing the two positive charges Q1 and Q2 at a distance of R in the vacuum. Now, if E is the electric field intensity, then obviously because these two charges are like charges, there will be a force of repulsion and the direction will be along AB extended. Along AB extended. Now, in order to use it, we will consider the force experienced by the charge Q2 due to Q1, because in this case what we are considering the charge Q1 as the source charge and Q2 as the test charge. Q1 is considered as the source charge and Q2 is considered as the test charge. So Q1 will be exerting a force on Q2 and that force will be obviously equal to the strength of the electric field multiplied by the charge at point B. That means the force will be equal to Q2 multiplied by E. E is the strength of electric field, or you can say electric field intensity. Now, in order to find this E, what we do? We consider a Gaussian surface, obviously, which will be again a sphere of radius r passing through B. It will be a Gaussian sphere passing through B and also having the radius r. So according to Gauss theorem, phi will be equal to Q1 by E epsilon naught, because in this sphere, Gaussian sphere, what is the magnitude of the charge enclosed inside? It is Q1. Inside the sphere, the charge is Q1. So, according to Gauss theorem, total electric flux phi will be equal to Q1 by epsilon naught. And you can see in this diagram, okay, the direction of E and the direction of R, they both are parallel to each other. That means since E is parallel to ds, so the value of E will be same at all the points on the surface. That means Q1 by epsilon naught E will be constant, it comes out, and what is left? Surface integral of ds. Any doubt? Because देखो, on every point on the sphere, the magnitude of electric field intensity is the same. For that reason, what will be there? We can consider E as constant. So it is out of the integral, and we have to just find the value of surface integral of ds. What is ds? Surface is the sphere. So area of sphere, that means curved surface area, that is 4 pi r square. That is 4 pi r square. So when you put this value, what you get? What you get? 4 pi r square. So q1 by epsilon naught is equal to E dot 4 pi r square. And when you find the value of E, this 4 pi r square will come on the other side. What you will get? Q1 over 4 pi epsilon naught into r square. This is the magnitude of the electric field at the point P due to Q1. This is E. Now, what is the force? In our previous formula we written force is equal to Q2 into E. E की वैल्यू आपने निकाल ली, फोर्स की वैल्यू क्या लिखी थी लास्ट इक्वेशन में? F was equal to Q2 into E. E की वैल्यू आपने अभी निकाली है Q1 by 4 pi epsilon naught r square. So when you put this value, what we get? 1 over 4 pi epsilon naught r square into Q1 by Q2. And this proves Coulomb's law. Final revision of this, and today we will conclude for this topic, and let us come back to our main slide. So today we have discussed about two important concepts. First was Gauss theorem and its proof, and the second was deriving the Coulomb's law using Gauss theorem. Gauss theorem says the total electric flux due to a charge in a closed surface is equal to 1 over epsilon naught times the charge enclosed by it. This is Gauss theorem. In order to prove that, we have used the concept of a small charge placed, making a sphere, then electric field intensity at that point, that is clear. In Coulomb's law, what we have done, we have taken two charges, Q1 and Q2, out of which we have taken Q1 as the source charge, Q2 as the test charge. Obviously, Q1 will exert a force on Q2. What will be the magnitude of that force? That force will be equal to charge at point B, that means Q2, multiplied by the electric field intensity, जो force लगा रही है. That means F is equal to Q2 into E. Now, my first thing is to find the value of E at B due to the charge Q1 at A. उसके लिए हमने क्या किया? गॉस थ्योरम का कंसेप्ट लिया. गॉस थ्योरम का कंसेप्ट लेकर E की वैल्यू निकाली. उस E की वैल्यू को हमने वहां पे पुट किया ds की वैल्यू निकाल के और कूलम्स लॉ को प्रूव किया. इफ यू हैव एनी डाउट you can ask me on my number and rest we will continue tomorrow. Thank you very much. Have a good day.
Thank you, sir.
Thank you, sir.
Have a good day.
Thank you, sir.
Okay, beta. All the very best. Take care of yourself.
Thank. Okay, sir.
Yes, sir.